Hello guys, someone has asked this doubt, so we can go through this once. Yes, good morning students. So the question is actually is for it to show bubble, a charge is given so that the surface charge density is sigma. So if excess pressure on the soap bubble is P, then and surface tension of the soap bubble is T, then what is the sigma? Is the question. So to understand this, we have to just first recollect back that what are the forces acting on it, so that it is in its shape. So here, due to atmosphere, atmospheric pressure acts from outside. Let us say in this direction by considering this is okay, and due to that, you can say a force also acts. That force can be expressed as a pressure into area. So here, as force equal to pressure into area, you can say force due to atmospheric pressure is equal to atmospheric pressure P naught into A the area will be the same area which is the flat surface is having that much an area it exerts, we can consider it as pi r square. So and again force due to the inside pressure is given as inside pressure into area, which is pi into pi r square, and force due to surface tension. Surface tension acts because soap bubble is considered to be having two free surfaces. So bubble is considered to be having two free surfaces. So on the circumference, surface tension will act downwards and inside circumference and outside circumference. So you can write it as surface tension force is equal to surface tension into the effective length will be taken as 2 pi r into 2. So it is 4 pi r into t or 4t into pi r. So whereas force due to electrostatic force, it can be as it is in a spherical shape. You can say that the force here, if the charge is there, means here everywhere the electric lines of force even outward directions. So that means you can consider that force is equal to pressure, electrostatic pressure into area. Electrostatic pressure can be expressed as sigma square by 2 epsilon naught. You have to remember this, sigma square by 2 epsilon naught into the area on which it is acting as pi r. So overall, as the soap bubble is in equilibrium condition, we can say the net forces acting on this will be equal to 0 in equilibrium. So net downward force equal to net upward force. So you can say atmospheric force, the force due to atmospheric pressure and the force due to what you call surface tension are acting downwards, and the force due to inside pressure and electrostatic pressure electrostatic force acting in upward direction. Hence, if we equate them, we get excess pressure is equal to 40 by r minus sigma square by 2 epsilon naught. Here excess pressure is given as P. So we can write it as P is equal to 40 by r minus sigma square by 2 epsilon naught. Okay, and simplifying this further, we get sigma is equal to 2 epsilon naught into 40 by r minus P under root or power half. Okay. And there was another question. If a cube lies at a distance of a along x-axis in this xyz coordinate system in an electric field whose electric field values are given as Ex is equal to alpha root x and Ey z is 0. That means electric field is acting only on x-axis as a function of alpha root x, where alpha is 5, which is given 5 units. So you can write it as alpha Ex is equal to 5 root x. That means x changes, electric field will changes. It is not uniform electric field; it is variable field. Then how to find the question is what is the flux? What is the flux through the cube? So as it is passing through this, so through the top surface, bottom surface, to the front surface, back surface, they will it grazes. It will not cross. So flux through those surfaces, four surfaces is equal to 0. Flux will crosses only the left side surface and right side surface. Through the left side surface, it enters. You can call it phi I, and it leaves here. You can call it as outward flux, inward flux and outward flux. Phi I is equal to EIA cos theta. EI is here it is at a distance of a, so you can write it as 5 root a into area of this surface will be a square into cos theta. Here electric field is to the right and area vector will be to the left, so angle between them is 180 degrees. So you can take it as cos 180, and hence you can express it as cos 180 is minus 1, so minus 5 into a power 1 by 3. Whereas outward flux to this surface is given as, because it is at a distance of here up to here a and this side length is a, so a plus a 2a will be the distance. So as x is equal to 2a here, so you can write it as 5 root 2a into area is to a square only and theta is 0. cos 0 here as electric field and area vector both are parallel. So it will be 5 root 2 into a square, root 2a into a square. This further I can write it as 5 root 2 into a power half into a square becomes a power 3 by 2. Right? So this is outward flux. The total flux is because the inward flux and outward flux are different, they are not equal. So the maximum one minus my minimum, or can say outward flux will be is positive, inward flux is negative. So outward minus inward is equal to this. So here 5, if you take out 5 into a power 3 by 2, if you take out, it can write it to root 2 minus 1, and simplifying this, you can write this, or approximately can take it as 2 units, 2 Newton meter square per coulombs, coulombs, with Newton meter square per coulombs. This is how you have to work it out. If there are any other questions, you can drop me a message, guys, in the chat box or in the WhatsApp so that I will respond here.